And we're back. No more scary zooms. Or do you want the scary zooms? Okay, well, not going to get them now. Let's see what you said to that. And we're back with 2 more examples on sequences and series. Hopefully you've done that exercise 3 on page 9, 1A, 2A, just to get you going. Welcome. Definitely do some more if you want some more practice. Or is 2 enough, or do you think, no, I'll do a few more? Yeah. So example 3. Second term in a geometric progression is -4, and the 5th term is 32. Determine the formula. Now, what's our general equation or our general formula for geometric progressions? Well, I know that Tn equals AR to the n minus 1. Okay, so let's see how we can use this. So this looks like when we did arithmetic progressions, we got 2 of these bits of information and we made a simultaneous equation. That's what we did for arithmetics. Let's see where this heads to. So Tn, so we got the second term is -4. So T2 is AR to the 1, right? So I'm not going to put the 1 there. And we told that T2 is -4. So that's what we got in one case. And we know that T5 is 32. So I don't need that. So T5 is AR to the n minus 1. So AR to the 4. Remember, we don't want to write 5 minus 1. It's a bit cumbersome. And we told that T5 is 32. Okay, now there are at least 3 ways to go from here that are all great and interesting and relevant. And we're going to kind of do one. Actually, let's just go to a little trick and say, well, it's not a trick. Well, it is a trick, I guess. And that is -4 equals this. I'm going to just write this one and I'm going to move it. No, I don't think it's going to let me do that. So I'm going to move this by rewriting it over here and say, well, -4 equals AR, right? That's what we had before. Now, here's a little fun thing we can do with simultaneous equations. We can divide the whole equation by the whole other equation. Now, what are we on about, right? What are we on about? So we can kind of go, that divided by that, 32 divided by -4, is the same as AR to the 4 divided by AR. In other words, what we're saying, and this is, I don't know, it's just, I think it's very cool. That is equal to that side divided. AR to the 4 divided by AR. That's pretty nifty, don't you think? And what's beautiful about that with geometric progressions is that 32 divided by -4, okay, that works out to be something quite cool, like -8. Over here, these A's cancel. 1 term over 1 term, cancel. R to the 4 over R, well, that's just, what is it? Well, it's R to the 3. And if R cubed is -8, what when you cube it gives you -8? Well, the cube root of -8, I mean, we could use our, whoopsie, there's our calculator, I guess, there it is all big. We could use the cube root of -8 and say, oh, but hopefully we knew that it was -2. So let's get back to where we were and say, well, R is -2, right? -2 cubed is 8. Is -8 at least. So there's our value of R. Okay, well, we want to find out what A is. So let's just sub into one of these formulae. I'm going to go for this one because it looks a whole lot easier. So I'm going to go from there up to there and say, well, -4 equals A and replace R with -2. Okay, so -4 equals -2A. Just showing a few extra steps. We don't need them. Divide by -2, divide by -2. So A equals 2. That's pretty nifty. That's quite cool. Now, the 2 other methods out of interest are rearrange this thing. So A equals -4 over R, sub in here. It's kind of the same idea. Did I cover things up? There's what was happening before. And the third method, which is quite cool, and just maybe shout after this if you're interested in hearing about more, I'll make another video, but I think this strategy is going to work well for us, is to say, well, if what do we say? T2 is -4 and T5 is 32. We can kind of think, how many jumps are we doing to get there? Well, from 2 to 3 to 4 to 5. So we must be multiplying -4 by something to the 3. So in other words, we must be multiplying -4 times r times r times r to get to 32. Hey, we're actually getting the same equation in the end. So just a quick aside, interesting. Do you want more on that? Well, then maybe we'll get there. Yeah, so there's a nice one. Oh, we haven't, there probably more questions. Which term has a value of -1024? Well, let's just finish off this previous question to go Tn equals a r to the n minus 1. Well, then we've done these types of questions. Which one has -1024? So this is question B. This was the answer to question A. So -1024 equals 2 to the minus 2 n minus 1. Divide both sides by 2. But are you getting a bit comfortable with this, kind of working out which one has an answer of what? Hopefully. So we've got -2 to the n minus 1. So -2 to the what gives you 512. Well, again, we can pop our calculator up here and go, well, 2 to the power of, I don't know, 5. No, that's 32. So we could play this game and go 9. Oh, look at that. So therefore, we know that 9 is n minus 1. And so n equals 10. Does that kind of fit in? Well, the fifth term was 32, 64. It feels right, if that makes any sense. Okay, last part, question C, determine the eighth term. How are we going to work out the eighth term? Well, we're just going to substitute, right? T8 equals, what was our formula? 2 minus 2 to the n minus 1. Into the calculator it goes, and where's the calculator? There, hello calculator. So we got 2 times -2 to the power of 7 minus 256 minus 256. Cool. Done. Example 4. Now this is a nice one. Calculator not going to help us too much because there's some algebra happening. The first 3 terms are an arithmetic progression. The last 3 terms are geometric progression. Determine the value of x, determine the value of y. How are you feeling? What ideas do you have at this stage? You can't say none. What are your ideas? You must have something going. Okay, well, I'm going to let's just go through. Here we've got that part there is an arithmetic progression, and this part here is a geometric progression. So from the arithmetic we know Tn equals a plus n minus 1 d. And for our geometric, we know that Tn equals ar to the n minus 1. Cool. Let's fill in the bits we know. Well, we know that a is 2. So already we know that Tn equals 2 plus n minus 1 d. And even in this one, a is x, so maybe not that helpful. Let's stick with our arithmetic for now. But we know 2 things. What do we know about arithmetic progressions, arithmetic sequences? Well, yeah, they go up by the same amount. So we're going to plus something. So in other words, 2 plus something is going to give us x, and x plus that same thing is going to give us y. In other words, x minus 2 is going to be y minus x. Think of, let me just throw another one up here in the corner in case we need it. As an example, if I had like 7, 10, 13, etc. Look, 10 minus 7 is 3, 13 minus 10 is 3. X minus 2 is the same as y minus x. Feeling okay? Cool. Now let's see what we can do with our arithmetic. Our geometric. So in our geometric, it's this part here. So our value of a, what is a for the geometric progression? Well, it's this first one here, which is x. So in other words, we know that Tn equals x r to the n minus 1. Okay. Now, what do we know about geometric progressions? Well, we know that they go up by a constant ratio. So by way of example, if we had 3, 6, 12, look how it's timesing by 2 each time. So 6 divided by 3 is 2. 12 divided by 6 is 2 as well. So this divided by this, y divided by x, must be the same as 9 divided by y. Now this looks a little hairy, so let's multiply this by y. So y squared. In fact, I just want to do this on a new line so we keep that. So we've got that, right? So let's multiply that by y and that by y, so it's the same. Let's multiply this by x and this by x. Common denominator, so y squared equals 9x. Hey, there's an equation with 2 variables. There's an equation with 2 variables. What do you think we're going to do? It's simultaneous equations. Yay, yay for simultaneous equations. And up to you how you go with your simultaneous from now. I'm going to rearrange this one and go, well, y equals, let's just plus x on each side of our equation here. So we've got 2x minus 2. Oh, there's a y. There's a y. So we can put this one, let's be nice and call that 1. And let's call this one 2. And we're going to say, let's sub 1 into 2. And therefore, when we see a y here, we're just going to write 2x minus 2 squared equals 9x. Solve. You're going to get a quadratic. The heart of this was setting up the simultaneous. X equals something, or x equals something else. And then you're going to sub back and you get y equals something, or y equals something else. So there we are. Is that it? Ooh, nice exercise to do. Exercise 4, 2 questions. Feel free to do more. That was that.